Hi, I'm Kevin Crowston. Welcome to my talk. I'd like to thank my co-authors and also acknowledge the support of the National Science Foundation for this research. So in our project, our goal was to support better coordination in data science teams. By coordination, we mean managing the dependencies amongst tasks. So for example, in data science, it could be that one person's working on data cleaning, other people are working on analysis using the clean data. And so those people would likely have to talk to each other or have some kind of plan about how the data are going to be structured so that it will support the analysis. But in our project, we were specifically interested in the possibility of Stigmergic coordination, which is coordination that's supported by communication via a shared work product. This was inspired by research that we had done looking at open source software developers who appear to need to communicate explicitly less because if they want to know what other people are doing, they can just look at the source code that they've checked in on GitHub or other kinds of platforms. In prior work presented at CSCW, we developed a theory of Stigmergy that identified 3 affordances that were necessary. Socio-technical affordances about making the shared work visible and mobile, making it combinable, making it legible. We also talked about how those were implemented in the system in a bit of detail. For the interest of time, I'm not going to go into that, but it is summarized in the paper as well as, of course, in the prior work. Just as a quick overview of the system, which is called MITST. What it does is to represent a data analysis workflow in R, a common data science platform, as a workflow. So a set of nodes that are connected by data flows, which provide a nice clean interface between the work. If you were to click on one of these nodes, you would see a Jupyter notebook with the code. You can also see some additional metadata, such as the person to whom the node is assigned, as well as a project status, which can be used for project management by the team. Another view is as a Kanban, so the team could get started by brainstorming the tasks that they're going to need and then track the progress of those tasks from not started through completed. Up here, you can also see another feature to support the collaboration, which is the ability to share the code. So there's a push function when you have finished something and you're ready to share it. You can push the code out to your team members. Similarly, when a team member gets a notification that someone else has updated their code, they can pull that code down when they're ready to merge it with their own. So the system supports that kind of sharing of the work. We had originally planned to do a quasi-experimental comparison of teams using MITS to RStudio, but we ran into some challenges in being able to do that. First, because RStudio is not instrumented the way MITS is, we didn't actually have access to the RStudio team interactions to be able to compare. And secondly, and more problematically, and somewhat disappointingly, we found that not all of the teams assigned to the MITS condition actually used the system the way we had intended. So maybe that wasn't surprising. But we were able to turn that to our advantage in the final study design, where we complemented the comparison of RStudio and MITS teams with a comparison of MITS users and non-users within the MITS condition. The problem, of course, is that's not a random assignment, so it's no longer really an experimental study, which does limit the conclusions that we can draw. We developed a set of 4 research questions shown along the bottom here, and for each we had a diverse set of data. We were drawing on experiences using the system with students in an introductory data science team project. And so for each of the questions, I'll describe the data that we used to analyze it. So the first was basically just, do the teams really use MITS? We answered this by looking at the workflow and the system usage log from the 18 teams that were using MITS in the in-person classes. So some actually used it pretty much the way we had envisioned. So this is a representation of a workflow from one of those teams. You can see that it has the structure where the data are read in and are then forked out to a number of different analyses. The color represents the person working on it. So this is a collaboration of 4 students. And you can see it's a nicely integrated network. In contrast, this is a network, or not a network, from another project where basically each person has their own node, and there's no collaboration amongst them whatsoever. As well, the size represents how much activity is done on the node in the system. So you can see that, in fact, very little is done on MITS in this, aside from just uploading it and submitting it. Probably most of the work was done offline in something like RStudio. In between, we have projects which have networks like this one, where there is some connection and some collaboration, but also people just working on their own. and not necessarily taking full advantage of the affordances that we had hoped they would. So to facilitate this comparison of teams that did or did not use MITs, we grouped them into 4 based on the number of nodes. So a small number of nodes suggesting non-usage like this one, the level of connectivity, so a disconnected network like this being second. And then for connected networks, we looked for structures like the one shown here, where there's a single node with high betweenness or multiple nodes with high betweenness, indicating some kind of reuse of the data. And just as a sort of validation of that, this is a plot showing those 4 groups. So fewer than 8 nodes, disconnected network, more connected networks with more central nodes, showing the usage of the Kanban features. So in principle, as people are doing project management, things would move through all the levels. You can see that more or less didn't happen for the small nodes, but there was extensive use for the more developed networks, suggesting they were actually using the system for project management. The second question was whether they were using the other affordances for sharing and combining code. Again, we looked at the workflows and the usage logs of the teams, but this time comparing non-users to users. The paper has a full analysis of the different functions. I'm just going to zoom in on one particular one, which is sharing code. So you can see in terms of the number of times people pulled nodes, meaning getting someone else's code, or push nodes, meaning sharing their own, that there's this clear pattern where the more developed networks, people did those kinds of code sharing more. So overall, this seems like the evidence that the teams that were really using MITs were actually taking advantage of the functions for making their code visible and combining it with other people's codes. The most interesting question was whether or not this actually supported Stigmergic coordination. We have 2 sources of evidence, one from a survey comparing MITs and RStudio teams. The analysis there, we basically did an inductive coding looking for discussion of coordination problems or mechanisms. For the RStudio groups, they reported things like face-to-face meetings, using meetings or Trellos for task updates, using WhatsApp to stay in touch, and even so reported problems actually sharing and reusing code. So just like being able to get someone else's R code and use it was a problem. In contrast, in the MITs teams, only 5 out of the dozens of people surveyed reported regular face-to-face meetings or other kinds of coordination technology. There were few reports of coordination problems. It's not that they didn't have any problems, but they reported fewer problems communicating and coordinating. It doesn't prove that they were coordinating stigmergically, of course, but at least it's consistent with it. The most striking evidence comes from our analysis of a few meetings of the distance teams that we were able to record. So we had 20, 25-minute meetings done by Zoom that we recorded and then coded in 2-minute chunks for what the team was doing. And there's this very striking pattern where the MITs teams in blue are spending more of their time over here on the left, which is actually doing the work. So coding, data prep, individual work, developing models. And in contrast, the RStudio teams in gold are over here on the right, doing coordination, things like status update, making sure they understand each other's code, planning future work. The one exception is tools, not too surprisingly, given they have a brand new tool. The MITs teams apparently spend more time understanding the tools. Unfortunately, due to some technical glitches, we don't have the second meeting, week 7, for the MITs teams, but you can see that the pattern for the RStudio teams is very similar, which suggests that it was not just sort of a one-off occurrence. So in summary, it seems like the people using the tool can in fact spend less time on coordination work and more time on actually doing the work, suggesting again that MITs is helping them to coordinate better. So in sum, Stigmergic coordination means managing the task dependencies on the signals from the shared work as opposed to explicit communication. We tried to enable these through the system features we implemented in the MITs system to support data science. And the evidence suggests that the users are able to make use of those features. It helps them to modularize their work, which reduces the coordination load and enables awareness of others' actions and thus easier coordination, supporting better data science projects.